very warm welcome to all of you joining this first webinar. My name is Henk Hoff, I work for EUROCONTROL. And again, welcome to this first webinar of a series of 3 webinars during which we will provide you with an overview of the GADSS. This will be the first webinar. In the second webinar, we will provide you with an overview of GADSS implementations. And the third webinar, we conclude with showing you how the GADSS will be used in practice. We will do that using a number of use cases. These webinars have been organized by EUROCONTROL in cooperation with the Irish Aviation Authority, the French BEA, which is Bureau d'Enquête et d'Analyse pour la Sécurisation de l'Aviation Civile, and by the ICAO Paris EURNet office. So I really like to thank the whole preparation team for their efforts. We have an excellent lineup of speakers and presentations, and I will introduce the speakers later when we start the panel. But before we start this first webinar, I would like to ask your attention for 2 opening addresses. The first one will be from Nabil Naomi, who is the president of the ICAO Air Navigation Commission, and he will be followed by the second opening address, and that will be given by Sylvia Gerer, and she is the regional director for the ICAO European and North Atlantic office.
Good morning, ladies and gentlemen. Thank you, EUROCONTROL, for the kind invitation to open this event. Today, 6 years after ICAO began the work on the Global Aeronautical Distress and Safety System, the GADSS, back in 2014, we are nearly finished adopting and approving the standards and recommended practices and the procedures for air navigation services. Those of you familiar with how ICAO works would agree with me that for ICAO it is like lightning speed. Let me start with a little history. The tragedies of Air France 447 and the Malaysian 370 highlighted a limitation in the air navigation system: the ability to identify and locate aircraft in distress. ICAO started work in 2014 with a multidisciplinary meeting with states and industry to review and determine a way ahead. General agreement was obtained that there was a need to track flights and the concept of operations and CONOPS needed to be developed. This was the beginning of the GADSS. The GADSS CONOPS was drafted with the assistance of GADSS Advisory Group, a collection of state and industry-nominated experts who worked hard on its development. It outlines the whole system from the need to routinely track aircraft through distress tracking and the recovery of data post-flight. The approach ICAO took in developing the SARPs has been iterative. Initial standards to require tracking of aircraft in oceanic areas, with a recommendation to do the same throughout the area of operations or the operator, leverage existing technology, allowing the provisions to be applicable in 2018. Tabletop exercises with the Normal Aircraft Tracking Implementation Initiative identified complementary SARPs, which introduced further flexibility into the existing Annex 6 provisions for aircraft tracking. The Normal Aircraft Tracking Implementation Initiative also recommended that ICAO develop a repository to facilitate contact between air operators and air traffic service units. As a result, the Ops Control Directory was launched over a year ago. It has had a regular stream of new registrations from air operators, and the majority of oceanic FIRs have complemented their details. Building on the experience of the aircraft tracking SARPs, further provisions were then developed for the location of an aircraft in distress, which require the aircraft to be fitted with a new device able to transmit information from which a position can be determined at no longer or not greater than 1 minute intervals. These performance-based provisions created a challenge. On one side, air operators have the flexibility to meet the standards with a variety of different technological solutions. On the other side, search and rescue coordination centers need a centralized information management solution to get the information in a timely manner. To meet this need and enable operators to provide this information while also ensuring SAR personnel had one central point of reference for all distress tracking location data. The location of an aircraft in distress repository, the latter, was envisaged. Workshop with industry and state representation validated the concept, and a functional prototype was developed earlier this year. That prototype will be further developed into the final production system by the end of next year and will incorporate all of the feedback received from air operators, air traffic service units, SAR, and aircraft tracking service providers. Now that we have a better understanding of how the system works, ICAO is working on amendments to Annex 11 and 12, which should be available by 2022 and which will bring to fruition the GADSS CONOPS. The methodology for the development of these provisions has proven to be very successful, and it also has much to do with the passionate and dedicated experts that worked on them. I want to take this opportunity to thank Mr. Henk Hoff, who chairs the GADSS Advisory Group and has been instrumental in this success story. Thank you, ladies and gentlemen. I wish you a fruitful meeting and have a good day. Thank you very much. Bye.
Good morning, good afternoon to everyone, colleagues and participants to the EUROCONTROL GADSS webinar series. Thanks to EUROCONTROL for your invitation and for allowing me to participate in your webinar series through this video. The ICAO European region covers a very complex airspace, 55 states. Certain states occupy multiple flight information regions, rescue coordination centers, and search and rescue regions, requiring much interstate cooperation between member states. Since 2016, the ICAO EURONAT office is working to improve search and rescue activities in the ICAO European region, following the recommendation where contracting states should coordinate their search and rescue operations with those of neighboring states, especially when such operations are proximate to adjacent search and rescue regions. While aiming for effective improvement in the implementation of search and rescue provisions and its capabilities in the ICAO European region, the ICAO EURONAT office proposed certain coordinated actions, including the establishment of the first European Search and Rescue Task Force in 2014. This group discussed, submitted concepts and filled gaps in search and rescue capabilities in order to improve the overall capability of the search and rescue system throughout the European region. A second task force was later established in 2019. In this same year, we held the ICAO Search and Rescue Workshop. The meeting, combined with the search and rescue exercise, was an outstanding two-day event with more than 120 participants and had the strong support and was organized in cooperation with the Civil Aviation Directorate of the Republic of Serbia. Based on the very positive outcome of this workshop, the ICAO EURONAT office planned a recurrence in 2020 of 2 more workshops with the same structure, but unfortunately it was not possible to deliver due to the COVID-19 pandemic. However, a solution was thought of when the ICAO headquarters offered an opportunity to promote our search and rescue activities via a webinar. As a result, ICAO hosted a series of 5 webinars from August to October 2020 and with them support search and rescue activities in the European region. Our purpose is to raise awareness about the current search and rescue activities in our region, including the 3 Maghreb states, share other ICAO regions and states' experience, and address regional search and rescue implementation matters. I would like to close by stressing the importance of our partnership with EUROCONTROL on the coordination and support of the work for the global aeronautical distress and safety system and on all search and rescue initiatives aiming to bring a closer understanding and cooperation among states on this crucial aviation service, especially at these times and under health emergency environments with the COVID-19 pandemic still around us. Thank you very much, and I wish you lots of success over the next 2 days with the GADSS webinar series.
Thank you, Nabil and Sylvia. Very kind words for you. Thank you very much. I can introduce the first panel for this first webinar. So I start with Declan Fitzpatrick. He's currently Manager Safety Regulation Strategy and Policy with the Irish Aviation Authority. In 2014, he was Air Navigation Commissioner with ICAO when the disappearance of MH370 brought the inability to globally track aircraft into sharp focus. Declan is a member of the GADSS Advisory Group. Philippe Plantin-Duc, Philippe, hi. Also a member of the GADSS Advisory Group. He works for BEA. I will not try to pronounce what this stands for again. Since 1993, where he starts as acoustic analyst. He has been involved in over 800 events, investigations worldwide, and he's the chairman of various international working groups. And he's currently chairing the EUROCONTROL Working Group 98 on the next generation of ELT, which stands for Emergency Locator Transmitter. And the third panelist is Guillaume Aiguin. Good morning, Guillaume. Guillaume is subject matter expert on crash protected flight recorders, flight data monitoring, and location of an aircraft in distress at EASA, that's the European Union Aviation Safety Agency. And he has been involved on the topic since 2009 in the aftermath of Air France 447. Guillaume has managed the related EASA rulemaking activities, and he has recently represented EASA in various ICAO working groups that develop documents related to the GADSS. So welcome panel, and we look forward to your presentations. The first two presentations will be given by Declan. He will talk about the overview of the GADSS and about autonomous distress tracking. Declan, the floor is yours.
Okay, thank you, Henk. Good morning, everybody. Hopefully we'll provide you a very informative session this morning. So again, Nabil already mentioned some of the background to this. The work on the GADSS ConOps, Concept of Operations, really began in March 2014. As Henk mentioned, I was with ICAO at the time in the Air Navigation Commission, and you know, the public response to the disappearance of Malaysia Airlines MH370 was very much incredulity, really, that you know, in the 2000s, that we could actually not be able to track an aircraft to its final location. So in response to that, ICAO did announce you know, a major flight tracking meeting, and as well industry was trying to initiate a number of events, and had announced at the time that they would introduce aircraft tracking within their organization by the end of that year. So there was a definite worry that, you know, we needed to introduce a standard to make sure that we always knew where aircraft was. Now, aircraft tracking itself was welcome, but it wasn't the only issue, and we were aware of this for some time before. Air France 447, for example, had aircraft tracking practically every 10 minutes, but it was 6 days before the first floating parts were found, and the wreckage was localized 22 months after the accident, and Philippe will give a very good presentation on that tomorrow. The effectiveness of ELTs in non-survivable accidents. We were well aware that ELTs were not actually designed to continue operation after a non-survivable accident. That's not their original design criteria. We also knew that in terms of the air navigation service provision, the timeliness of identifying distress phases, there was definite room there for improvement. And likewise, in terms of global SAR capabilities, we knew in ICAO that in some regions, at least, not so much in Europe, that the SAR capabilities were not there to actually go and rescue people if needed. So what we really needed was a holistic view of the issues involved in aircraft tracking and in search and rescue and in accident investigation. At the time, we were discussing as well the First Amendment to Iko Annex 19, and we had this total systems approach concept in that revision, and that was the approach we took. So at the meeting, the multidisciplinary meeting that was organized by Iko and IATA, we took a recommendation to produce a ConOps. So the ANC president at the time established an ad hoc working group to develop the ConOps. The first meeting of the ConOps happened online. It was a bit of a novelty at the time back in 2014. Now, obviously, it's part of our daily routines, but we had our first online conference on the 3rd of June 2014. We identified a number of issues there. The existing air navigation provisions may not allow identification aircraft experience a normal event, etc. This first version of the ConOps was actually produced less than a week after the first meeting. So a lot of work went into it in those early days. Rolling on then to, I think it was June 2017, and about, I would imagine, 50 different draft iterations of the GADSS, we get to what is still the current version, version 6. So what it set out was the specific issues that the GADSS was designed to address. The late notification of SAR services when aircraft are in distress, missing or inaccurate end-of-flight aircraft position information, and lengthy and costly retrieval of flight data for accident investigation. So the objectives we set were to ensure timely detection of aircraft in distress, and this would now allow timely initiation of SAR actions, ensure tracking of aircraft in distress and timely and accurate location of end of flight, enable efficient and effective SAR operations, and ensure timely retrieval of flight recorder data. So we came up with this graphic at the time. It's very simple, but what you can see is the key components of the GAD system. So at the top, in terms of technologies, we spoke about the aircraft tracking, and this basically was to use the existing technologies on aircraft to provide a 4D position every 15 minutes. Autonomous distress tracking we'll talk about in more detail in a few moments. And then the post-flight localization and recovery technologies as well. And this is to aid primarily in the location of the aircraft and then in accident investigation post the accident. But what was also very important was the whole issue of the ability to share data. So clearly in what we could see, there was issues in how we would share data between the airlines, the air traffic services, rescue coordination centers. So very much a big part of the ConOps is data sharing capabilities with the SAR and accident investigating authorities. So over the last few years, we've developed these standards and recommended practices for these key parts. Specifically in relation to aircraft tracking, you will find them in section 3.5 of Annex 6, Volume 1. Likewise, location of an aircraft in distress talks to the autonomous distress tracking concept, and that's in 6.18. And then flight recorder data recovery is covered in 6.3.5. And you will see a lot more information on these over the presentations over the next 2 days. Just to highlight again that we saw a big part of this was the ability to share data and how data moves through the system. So if you look at the actual GADSS ConOps, you will find some very good detailed graphics on how this happens and swim lanes, etc., drawings of how the data will flow through the system. So you will see, for example, there on the left, how ADT data will move to the ADT service provider onto the MCC through the GADSS information management system and how it can be shared with the ATSUs, etc., and back through the RCC to the SAR service. But again, you'll hear a lot more about this in detail in the presentations to come. Sorry, just to go back there, two of the important parts to make that data sharing happen was what we referred to at the time as the distress tracking repository and the point of contact repository. So these have now been fleshed out and explained in greater detail. And what ICAO now have is the what they call the Ops Control Directory, which is basically sharing data about air operators and air navigation service providers, and what they now refer to as the ladder, the Location of Aircraft Distress Repository, aircraft data repository. And you will hear about this tomorrow as well from ICAO. If you need some additional information, ICAO has put together quite a good site on global tracking initiatives, and you will find copies of the various documents in there, including the ConOps and guidance material in ICAO Doc 10054 and in Circular 347 related to aircraft tracking. So that's a basic introduction to the GADSS ConOps and how it came to be and what its main constituent parts are. I'm going to keep going now and talk more specifically about autonomous distress tracking and just give you some more information on that. So in terms of a definition, this is the one used, the capability using transmission of information from which a position of an aircraft in distress can be determined at least once every minute, and which is resilient to failures of the aircraft's electrical power, navigation, and communication systems. So an important distinction to make already, and this kind of evolved after the ConOps last version, was to distinguish between the aircraft distress tracking capability on the aircraft, but then the broader ADT function, which includes an airborne segment, an air-ground communications link, ground-based systems, and terrestrial communication networks. And I'll explain that a little more in a later slide. So the actual requirement in ICAO Annex 6, 618, and it's defined as location of an airplane in distress, requires aircraft with a mass over 27,000 kilos, which will be issued with an individual certificate of airworthiness after the 1st of January 2023. So that's basically any new production aircraft coming off the production line should have ADT. It also has a requirement for operators to make position information of a flight in distress available to appropriate organizations as established by the state of the operator. And what this effectively tries to establish is that to a reasonable extent, the location of an accident site can be determined to within a 6 nautical mile radius. There's additional information in ICAO Annex 6 in the Appendix 9, and you'll see this here. So a definition of aircraft in distress. This was quite important because, we don't want false distress events. The definition that we came to was that an aircraft is in a distress condition when it is in a state that, if the aircraft behavior event is left uncorrected, can result in an accident. So there's a couple of important notes that go with that definition. Aircraft behavior events can include, but are not limited to, unusual attitudes, unusual speed conditions, collision with terrain, and total loss of thrust propulsion on all engines, and ground proximity warnings. And another key point is that a distress alert can be triggered using criteria that may vary as a result of aircraft position and phase of flight. Further information and guidance was then provided in EUROCONTROL 237, and that is available to buy actually on a number of sites. So the basic ADT requirements that we defined at the time. So an airplane distress shall automatically activate the transmission of information from which its position can be determined by the operator, and the position information shall contain a timestamp. So this is a basic 2D requirement once every minute, which is defined a little later, and it shall transmit when the aircraft is in distress. Now this means it can actually transmit before the distress event, but you just need to be able to recognize that a stress event has happened. In case of a trigger transmission system, initial transmission of position information shall commence immediately or no later than 5 seconds after the detection of the activation event. So if you have a solution that is not transmitting normally, but when the aircraft goes into distress, it must start transmitting within 5 seconds of that event occurring. These times, you know, the 5 seconds and the 1 minute transmission rates, these were all determined from research done after Air France 447 as appropriate time. So in the case of the 5 seconds, it related to analysis of aviation accidents that occurred in which, you know, the research kind of found that within 30 seconds, a lot of these accidents had gone from the distress state to the actual accident within that time frame. So it was felt that 5 seconds was as much as we could allow to ensure that we got at least one transmission. We also put in that it should be possible for this transmission to be activated manually. So if the crew should decide that they should start transmitting, they can do. And another important point was that the mechanism that started the transmission should be the only mechanism to deactivate it. So if the aircraft automatically started transmitting, it should not be possible to manually turn it off by persons on the aircraft, as an example. Then when it came to actually the accuracy of the position information, the standard we decided was to apply the same standard as that for ELTs. And it also required that the coordination be established between ATSUs and the aircraft operator. So there is more detailed guidance on this available. Again, it's contained in Doc 10054, Manual on Location of Aircraft in Distress. It also covers the flight recorder data recovery information. And it goes through the basic ADT systems overviews, but also covers how the data is shared between operators, ATSUs, and RCCs. And just to come back to the notion of an ADT versus an ADT function, this diagram that's contained in the guidance material in the Doc 10054 gives you a kind of an overview. So just to explain, there is an airborne segment, and this is effectively the equipment on the aircraft. That equipment must communicate, so it does that through an ADT service segment. And this is controlled by the operator. So that's the overall operator ADT system. And then the actual output of that system needs to be shared into an information management subsystem so that RCCs and SAR can obtain that information. So that just gives a broad kind of overview of the overall ADT system. There is guidance, other guidance material as well. I've mentioned one or two of these. The EUROCONTROL ED 237 provides criteria to detect in-flight aircraft distress events. The ARINC 680 ADT that describes the technical requirements, architectural options, and recommended interface standards to support ADT. And we also have now EUROCONTROL ED 62B, which defines the ELT DT. And Philippe will give you more information on that too. So there are quite a number of ADT process flows as well contained in the CONOPS, which shows again how the data is shared between the operators, the ATSUs and RCCs. It covers a number of options, including the COSPA SARSAT ELT DT, which you will see more about. But just in basic terms, how the data flows. So if you have an ADT event or a potential distress event, if it is an ELT DT solution, that will automatically trigger on the aircraft. That will provide data to COSPA SARSAT, generating an alert, which will go to your rescue coordination center and shared to the applicable SAR assets to go to the aircraft. Slightly different with other ADT solutions is where the process initiates a trigger, which is fed to the operator, and the operator will decide then whether it needs to notify the ATSU or into a other coordination center route, and again, notify the SAR assets. But just to highlight that there is a triggering stream, but also then there's the data sharing stream. So you will trigger, the operator will trigger an alert and advise the RCC, but this will then allow the RCC go access the ladder to get the actual 4D1 data that would be available in the ladder for that event. So that's a very basic overview of the ADT system. You will see examples tomorrow that, actual solutions for ADT that are now available in the market. So that's it, Henk. That's just a quick overview of ADT and of the GADSS. So back to you.
Thanks, Declan. With this, we have started the first webinar with an overview of the GADSS and a presentation of the autonomous distress tracking function of the GADSS. So the next presentation will be on the flight data recovery and post-flight localization function of the GADSS, and that will be given by Philippe. Philippe, floor is yours.
Okay, so thank you, Henk. So good morning, everyone. So I will present I will detail the other pillars of the GADSS function, which is the post-flight localization and flight recorder data recovery, standard and recommended practices. So first of all, I would like to come back to what happened during the AF447 investigation. So I led with a colleague from BA some international working group activities before issuing safety recommendation. So we wanted to make sure that the safety recommendation not be addressed to only a single event, but in fact was using many different events that we have on the database. So based on the international working groups performing cost-benefit analysis as well, we issued two kinds of safety recommendation. One on the medium term. Medium term wanted to address, in fact, existing aircraft, so existing type of aircraft, but new built. So this is dealing with regular or triggered transmission of position and or flight parameters. And the second set of safety recommendation was based on long term. Long term was for new type of aircraft, so Airbus A390 or 797. So because we performed some cost-benefit analysis again, and we were expecting that on this new type of aircraft, we can expect some installation of deployable recorder to assess the flight recorder data recovery. Just to explain you a little bit about the process at ICAO. So the first safety recommendation we issued on the short term was for the low frequency beacon attached to the aircraft. This low frequency beacon will be emitting some sounds underwater, and then it will be helpful to find the wreckage. So we issued safety recommendation. So ICAO took this recommendation and asked the ICAO flight recorder panel to make some proposition. And these propositions were forwarded to the ICAO Air Navigation Commission. So then the Air Navigation Commission proposed some words to include on the Annex 6. There is first a preliminary review with a state letter sent to all ICAO contracting states. So some comments received, and then based on these comments, there is a final review, and then there is a publication of Annex 6, which includes the words that were proposed. So as you can see, in 3 years, we succeeded to have an evolution of Annex 6 regarding ULD SARPs. And then we issued as well, a little bit later, based on the work on the second working group, some additional safety recommendation for ELT, so emergency locator transmitter distress tracking, because we found that it was very important to have information sent in flight, because we know that ELT are designed to find survivor, but when you have a high energy impact, ELT will not survive. And so it was considered very important to be able to transmit position while in distress before impact. And the second issue was the deployable recorder. So same process, we sent the information to ICAO. ICAO requested ICAO flight recorder panel to assess and to propose some text. This is what we did. So we sent the proposed text to the Air Navigation Commission. We tried to have basic information, 1 minute interval, 6 nautical miles. It was addressed by Declan just before. But the Air Navigation was not convinced by the work. So he asked the ICAO flight recorder panel to work on it again. So we did tweet the words, and then we did propose again some text. And Air Navigation asked again the flight recorder panel to review the text. And so the MH370 accident occurred, and ICAO Air Navigation Commission asked the flight recorder panel to make some new proposal. And then he went directly to the Annex 6 standard. And so you have on the Annex 6 some text regarding autonomous distress tracking and flight recorder data recovery. So this is to show that the process is complex. So what we did propose was analyzed by ICAO to be, I would say, consistent with what is on the Annex 6 and was robust enough to be inserted on the Annex 6. So now, in fact, I will speak about the two pillars of the GADSS function. So the post-flight localization and the flight recorder data recovery. I will not present again the diagram that was already presented by Declan. So regarding post-flight localization, in fact, we had already on the Annex 6 some standard and recommended practices for emergency locator transmitter. So as I said earlier, the ELT is designed to find survivors, and I will say between brackets, it is normal that TZLT be destroyed during a high energy impact. ELT can survive already 500 Gs, but nevertheless, you don't expect when you have a high energy impact to have a system be able to be still active the impact and be able to transmit information to the satellites. So the impact or the side effect of the autonomous distress tracking standard that was detailed by Declan on the 6/18 was a modification of the standards and recommended practice for ELT. And you will see on the bottom of the page a new line dedicated to the ADT, which says that you need at least one ELT and a capability to meet the requirement of 6/18. So up to incursion of this new standard, in fact, on board all large transport aircraft, you had 2 ELTs. One of them is automatic, and the second one is non-automatic, I will say. And this is for all certificate aircraft, certificate of airworthiness, first issue after 1st July 2008. And with the 6/18, now you have a note saying that when you have an equipment that comply with the 6/18, an automatic ELT is not required anymore. And I consider that this is a main issue. So as I said, the ELT is dedicated to find survivor, and the autonomous distress tracking is mainly to provide a position within 6 nautical miles and the 1 minute 6 nautical mile were detailed, in fact, on the international working group that were created in the framework of AF447. And so it is good when you are over oceanic area to have a position at 6 nautical mile, no doubt about that. But if you have such a precision when you are over terrain, it could be a major issue for SAR services. So definitely having 150 square statute land miles over a mountainous area is too much to be able to find survivor quickly. So during the 13th Air Navigation Conference, the 44 European states and Eurocontrol presented a working paper explaining, in fact, that the new ADT standard will be, I will say, not of sufficient precision for SAR in mountainous areas. So we had a detailed working paper defining the needs for a better location for survivors. And the results, nevertheless, of this, I would say, the work presented on this working paper, the result was that there is a need to review the need for requirement for performance-based standard to accurately determine the location of the end of flight. So then various working groups were consulted. First of all, there was a guide advisory group that was consulted to propose some needs. And as well, the ICAO air accident panel is as well involved to provide feedback on ELT activation, because this is on the report from accident investigation that you may find some information regarding how the ELT worked on some accident and if it was efficient and working. So all these groups are consulted, it's not yet completed, to show the needs. So far from, I would say, the consultation of this group, what we can say is the expectation we have is that there is a need to have an accuracy of about 200 meters on 2D accuracy as a minimum, and with some redundancy regarding GNSS position and 121 homing. So it means that it is very important to have still the people that are equipped with 121.5 MHz homing signal to be going on site. And we have seen that in many times on general aviation, it is the best way to reach very quickly the site crash. So on parallel of that, we have an improvement of the EUROCONTROL document for the ELTs. So on this document that was published in December 2018, you have an increased survivability of automatic ELT that will greatly improve, in fact, the survivability of automatic ELTs for GA, for large transport aircraft. And we have as well the document defining the criteria to trigger the distress situation. So regarding now from flight recorder data recovery. So we have a standard on the Annex 6, the 635, that will impact the new type certificate aircraft. So again, it is for Airbus A390 or 797, so none of the existing aircraft. So this is for new type certificate aircraft after 2021. And as you can see, this is to recover flight recorder data and make it available in timely manner. So as soon as you have performance-based standard, you will need some manual. And the manual that was already detailed by Declan, the 10,054, will cover as well flight recorder data recovery. And on the second SARPs we have on the Annex 6, this document will explain what is the capabilities of the operator. So all the text is explained on the manual. So on the manual, you will find all the SARPs and all the details to better understand the SARPs. So very important document that you have to check if you're interested. So the Ico Manual contains, in fact, two sections, one dedicated to ADT and second one dedicated to the flight recorder data recovery. So we made sure on this document that everything will be explained. What does timely mean, for example, or what is the description of the operator capability, and as well, for the flight recorder data recovery, we are giving example of technology, but we have still using words that allows, in fact, in the future, new technology that may arise in 5-10 years' time. So one of the technology to recover data is automatic deployable flight recorder. And we have already some standard detail on EUROCONTROL, so EUROCONTROL ED112A, that explain, in fact, how it works, what are the minimum survivability numbers, etc. But there is as well some other technology, like continuous or trigger transmission of flight recorder data. We imagine that in real time, you will trigger or you will send audio information, parameters, data link, etc. Or you can start using the triggering criteria that have been used to detect or to trigger the distress situation. So we are trying to be fairly open to make sure that you may get data very quickly on the ground after the impact. And we are trying to provide as well in the manual the kind of protection of the data transmitted from the aircraft to the ground, or the priority of transmission. When you have to transmit audio, you have to transmit parameter, data link, images. So all these things works. So just to summarize, in fact, the means of compliance for the flight recorder data recovery, there is already an ICAO standard, some SARPs dedicated to the installation of fixed combined recorder. So it is mandatory, as you can see on the future built aircraft, one fixed recorder on the front of the aircraft, one fixed combined recorder on the back. So all these two recorders are recording audio, parameter, data link, flight control, flight crew machine interface recording, images. So, and it will be on new type of aircraft after 2016. Nevertheless, we can see that on, I would say, existing design, both Airbus and Boeing have decided to install combined recorder on both on the front and in the back. And very quickly in 2022, the new built aircraft, in addition, will have 25 hours CVR. So we will have, I would say, good combination of recorders on board. And then to comply with the flight recorder data recovery standard, you may have on the back an ADFR that will replace the fixed combined recorder, which is on the back. So you will have in such a case, two combined recorders, a fixed one on the front and the deployable one in the back. And you may select another solution that will be, in fact, the streaming of flight recorder data, again, continuous streaming or triggered when in distress. But this streaming of data will not replace one of the two recorders. So we are not sure yet that we will have exactly the same data than the one that you have on the flight recorder, the fixed one. And so this transmission of data will be in combination, in addition with the fixed recorder that are on board the aircraft. So then you have an overview of what will be the flight recorder data in the future for the quick recovery of all this data. So on the conclusion, I will come back, in fact, on the ELT requirements, because I think that the working paper that was submitted at the 13th Air Navigation Conference clearly defines the needs. It was proposed by 44 states, which is a little bit less than a fourth of the states, ICAO states representing at ICAO. And definitely we need to have a performance-based standard or modification of the existing standard. And we need to make sure that we will have in the future some standard and that provide better accuracy if you have survivors. And we don't have to wait for a new accident to make sure that we will have this standard. So definitely we need the cooperation of SAR community, accident investigation community, to make sure that we will have robust ELTs and working when needed to find and to locate survivors. So this is the end of my presentation. Thank you.
Thank you, Philippe, with the presentation of the location, flight data recovery and post-flight localization, one of the 3 GADSS functions. During this webinar, the first webinar, we will, as you have found out, inform you about the overview of the GADSS, its functions, the work that's happening in ICAO. We will soon hear about Guillaume about the regulatory work that is taking place. This is all background. In the next webinar, which will be this afternoon, at least in the afternoon in Brussels, we will learn about industrial developments, real implementations. And the third webinar, we demonstrate to you how this is going to work all in practice. So again, that's the buildup of these 3 webinars that we have put together. So the next presentation will be given by Guillaume.
So good day, everybody. So this presentation will be dedicated to the Yasa approach to location of an aircraft in distress. I should say maybe a few words about Yasa because I see a lot of participants which are not from Europe. Yasa is the European Union Aviation Safety Agency. We prepare implementing rules applicable to all EU member states, plus 4 states who have a kind of contract on aviation rule with the EU. So in total, 31 states, and this encompasses air operation rules, applicable to ATM ANS, to flight crew licensing. We also issue airworthiness standards, and we certify all European products. Okay, so now my first slide is just to give a very quick overview, a very quick mapping of the transposal of ICAO provision into the EU system. The left-hand side graphic, you have already seen it, with the 3 components: aircraft tracking, autonomous distress tracking, alias location of an airplane in distress, and post-flight localization recovery, encompassing ELTs on the timely recovery of flight recorder data. Very important in this graph is all this is meant to for the benefit of 2 stakeholders: search and rescue authorities and accident investigation authorities. Now, to make it clear, we have implemented all these standards in the EU Air Operation Requirements, in particular in Part CAT of the EU Air Operation Rule. CAT stands for Commercial Transport, but I will focus only on location of an aircraft in distress. It's in a paragraph numbered CAT GNMPA 210, and it's applicable to aeroplane manufactured as of 1st of January 2023. The next very important thing for you to be aware of is that the implementation of the autonomous distress tracking concept, as was presented by Declan, into the EU operation rule, is not a one-for-one. There are some differences. There are some good reasons, historical reasons for these differences. But as you can see on the right-hand side, what CADGen MPA 210 requires are robust and automatic and accurate means to determine, following an accident where the airplane is severely damaged, the location of the point of end of flight. So at first glance, it looks very different from what you have on the right-hand side. However, as was also mentioned by Declan, Appendix 9 to Iko Annex 6 Part 1 states the aim of the SARPs on location of an airplane distress, which is to establish the location of an accident site and even, let's say, provide an accuracy objective of 6 nautical miles. And in fact, this aim was made a requirement under CADGen MPA 210. And so we have a more, let's say, here, conceptual performance-based requirement than maybe the IQ approach. Besides that, there are some differences regarding the applicability set. And also, one thing on which Philippe insisted a lot is the possibility in Iko Annex 6 Part 1 to replace an automatic ELT by an ADT system. It's permitted by section 617 of Iko Annex 6 Part 1. And we have a similar flexibility. In addition, a system compliant with CADGen MPA 210 may even replace a low frequency underwater locating device, which is used to locate a wreckage underwater. So these are the fundamental differences that you should be aware of. And now I will focus on a notice of proposed amendment, that is to say an official proposal by EASA of a change to rules, actually not to rules, to means of compliance on certification specification. It's part of an EASA rulemaking task with the code RMT 0400 that you can find on the website of EASA. The scope of this task is to adopt means of compliance and guidance for the rule. CADGen MPA 210, the rule is already published. It was actually published 5 years ago. But at that time, it was very early stage, let's say, also at ICAO in terms of development of guidance. So our rulemaking activity was put on hold to see more of the concept that ICAO was developing, and therefore we are now still in the process of adopting means of compliance. Clearly, this rulemaking activity will not amend the rule itself. It's not in the mandate, so the differences you have seen before will not be corrected by this proposal. The approach we took for this rulemaking activity was a performance-based approach. And from the start, this was, let's say, a policy given by the European Commission to have a performance-based approach, because at the time it was started, or at the time the rule was adopted, the technology were just, let's say, identified but not really developed, not ready to be implemented. So as you have seen the requirement, there is only a concept and a definition of an applicability set, and then the rest needs to be defined, particularly the performance objective. And our strategic decision was that we would apply the same performance objective to all candidate solutions. If they would meet this performance objective, then they would be, let's say, they would be acceptable. And from this performance objective, we would define conditions and then decline them in acceptable means of compliance and certification specifications. By doing so, what was very important for us was to not lose sight of the SAR needs and of the investigation needs. In particular, as you have seen before, there has been a lot of, let's say, discussion about the accuracy that is, let's say, needed to meet the SAR needs. This was in the presentation of Philippe before. For us, the baseline is not the historical performance of ELTs, It's the performance obtained with the latest standard, that is to say, for instance, EUROCONTROL 62B, as was mentioned by Declan before, which was issued in 2018, and the latest performance achievable by the International Coast-Path SAR program, including the MEO-SAR component. Addressing the needs of SAR is first and foremost, of course, do not harm, do not have a negative impact. So in terms of their workload and on their efficiency. This is in a nutshell the process we followed. So it was a top-down approach from the definition of common performance-based objective to technical conditions, and then transposing them into let's say a regulatory text. Of course, this was an iterative process. We had also some consultations through workshops on written consultation. The technologies that could meet the ADT concept are the one below, as you can see here. The emergency locator transmitter for distress tracking, or ELTDT, was explained by Declan. Another concept very similar is that of high rate tracking. It's also appear in the NPA that 2020-03 that was published. It's a similar concept with the difference that the transmitter is not an ELT, and therefore the transmission is not using the infrastructure of the International Coast-Path SAR program, but other means such as commercial constellations. We have, in addition, because our requirement just require locating the point of end of flight, we will accept as a means of compliance systems such as based on an automatic deployable flight recorder, as was explained by Philippe before. This is a recorder which is automatically deployed upon detection of deformation of the airframe during the crash. This is equipped with an integrated ELT that automatically starts transmitting. So for the purpose of the EU requirement, an automatic deployable flight recorder could also meet the intent. I would like to spend the rest of this presentation in emphasizing some performance objectives that we have identified in the framework of this rulemaking activity, and that we believe are not yet really addressed in the ICAO SARs, but are quite important for a successful implementation. First, there will be three aspects related to robustness, and the very first one is the robustness of the airborne system. It's quite trivial, but we want the performance of the airborne system to not be affected by environmental conditions encountered during most accidents within the scope. For us, the scope is an accident where the airplane is severely damaged. For the ADT, it's a distress situation. However, a distress situation may also end up in exactly the same, in a hull loss. And in a distress situation, if you look at the triggering criteria, it is likely that the equipment it is possible that the equipment is submitted to demanding non-normal environmental test conditions. So we want to apply for that types of equipment environmental test conditions such that it will continue operating under this condition. Because we allow the transmission after a crash, then for this equipment that should be operated after a crash impact, crash test conditions would be applicable. The second robustness aspect we would like to have better covered is the robustness of the link from the airborne system to the communication infrastructure. That is to say, to put it more practically, to the satellites, for instance, or to the ground sensor that will detect and process the signals. This link should be good, not only during normal operation, but under conditions that are encountered in actual accidents, as shown by historical accidents, in particular during loss of control. So when attitude, pitch and roll attitude values of the aircraft, pitch and roll rate values are quite high when there is maybe overspeed or a high vertical speed. This is under this condition that the system is expected to perform. And the third aspect related to robustness is the robustness of the communication infrastructure itself. And here we rely on concepts that are commonly applied to communication systems and communication infrastructures. Criteria such as availability, what percentage of the time the infrastructure is available, is ready to operate, integrity, the capability to detect, process, and transmit information without undetected errors, the capacity, that is to say the capability to process simultaneously signals coming from multiple aircraft, and the coverage in time and space. And here we are looking for global coverage most of the time. My next slide is about accuracy. I've covered robustness. Another performance objective where we want will be probably more demanding than the SARPS is accuracy. I think this topic was already quite well explained by by Philippe. I just like maybe to add that we will make a distinction between non-survivable accidents, where for us an accuracy of 6 nautical miles is acceptable because the stakeholders we want to support are the investigation authorities, and we should bear in mind that the flight recorders carried on board such aeroplanes, they are equipped with underwater locating devices. So even if it's not maybe the best solution for investigators, it's acceptable to have an accuracy of only 6 nautical miles for performing underwater search operations. When the rescue of survivor is at stake, a much higher accuracy is required. The homing signal is has been pointed to us as essential for operations with mobile SAR facilities. All mobile SAR assets or facilities are equipped with homing direction finders, and this is a signal they really need to operate. But we should bear in mind that the accidents that triggered all this rulemaking activity, in particular the Airfront 447 and MH370, they were accidents over oceanic areas where the aircraft sunk before the SAR teams could be in the vicinity. So there was no homing signal left to guide them, and therefore the transmission of signals with a high accuracy is still important to give a chance to SAR teams to rescue survivors. And then the last aspect I'd like to address is the impact on SAR, on search and rescue authorities. And here we have a first difference significant difference I'd like to highlight is that we have proposed in the NPA, and for timing we still intend to require that data stemming from an activated airborne system are automatically transmitted to the competent SAR authority, meaning the search and rescue point of contact designated by the state to receive emergency signals, similar to an ELT. Why? Because this information pass has proven very effective. It provides for a quick and reliable transmission of data. And also what is important for us is that there is a time objective. I think this was mentioned also by Declan, but unfortunately in the SARP there is no time objective, and we want to set a time objective that is compatible with the time frame for deploying SAR mobile facilities. It's important for RCCs to know where the accident site is located, because depending on where it is, they will have a different strategy and maybe deploy different mobile facilities. the concept of making the data available to the operator as is specified in the SARPs for us is not a must. So we do not yet intend to require it. We are monitoring the development of the ladder. So maybe when the ladder will prove a successful project, we would also like to take advantage of this. But for the time being, it's not a requirement. Related to the previous requirement, we will require a high level of reliability of the design of the system, in particular with regard to erroneous automatic activation, sometimes called nuisance activation. Because the aircraft in the scope make a significant number of flight hours, or at least made before the COVID-19 pandemic. So if you have 50 million flight hours per year produced by such aircraft, if let's say the design does not achieve a sufficient reliability with regard to erroneous automatic activation, this could have a significant impact on RCCs. Worldwide, in 2018, there were 36,000 alerts received by RCCs, out of which 20,000 were stemming from ELTs, the rest from APFs and PLBs. And so, in order to not have a significant increase of erroneous automatic activation or the significant increase of false alerts, we will set a major failure condition for the erroneous automatic activation. And finally, we propose in the NPA to require that the Airborne system automatically transmit deactivation signals when it is deactivated, because this information is also very probably very important to be used and can be in the future. We think it will be more and more used to confirm the situation of an individual aircraft. And it will help, in fact, determine whether the transmission of signal stopped because the system was deactivated manually or automatically, or for another reason, such as, for instance, destruction of the system through a crash impact. And so that was the end of my presentation. So the story is going on. We are now in the time of processing comments on the notice of proposed amendment I mentioned before, and NPA 2020-03. And just for your information, so there were a lot of comments, and we have been reviewed them carefully. We intend to adopt the provisions in the first quarter of 2021. Thank you for your listening.
Thank you, Guillaume, and thank you for this presentation about the regulatory efforts in Europe. So thank you for that. So may I ask all the panelists to switch on their camera, because we will start the Q&A session. And during the Q&A session, we will try to respond to your questions that have come in, and also maybe other questions that are coming in. So to start with the questions that are on top. First, let me, that was a question I answered already, is about the slides. Will they be made available? Yes, they will be made available. We will have an event site during which, from which you can download them. And you will also be able to download the recordings. So all of that will be available post this event. So that has been answered. So there were a couple of questions related to basic ADT requirements. The one of 5 seconds until first transmission will be difficult to reach for COSPA SARSAT ELTDT. You will hear more from COSPA SARSAT in the third webinar, which will be tomorrow. Guillaume, you offered to give your view on this. It relates to performance. Maybe you can say a few words about that question. And if you do so, maybe you can turn your microphone a little bit lower or higher, and that will improve the sound. Yeah, okay, thank you.
No, in fact, I believe Danny Saint-Pierre provided a reply in writing, which was very accurate. So I do not have too much to add to that. At that time, I wanted to reply what Danny replied, that the COSPA-SARSAT document applicable to first and second generation beacons, so it's T001 and T018, they specify that the LTDT must transmit at a 5 seconds interval, I think in the first 2 minutes. And so it is indeed part of the specification applicable to an LTDT.
Okay, thank you. A question from for Philippe. You used the abbreviation FCMIR. So obvious question is, what does that mean? And what is the ICAO document that incorporates the standards for the FCMIR? So Philippe?
Yes, so FCMIR is Flight Crew Machine Interface Recording. Just to explain the rationale of this new standard that you can find on the Annex 6, so is 634, which details the standard. In fact, the BA issued a lot of safety recommendations for image recorder. And so the ICAO Flight Recorder panel was proposing some standard. And in fact, now the tendency for ICAO is to have performance-based standard. And this is, I would say, the performance-based standard for image recorder. But you may have other solutions that comply for to this standard, in fact, as well.
Thank you, Philippe. A question from for Guillaume. Do we have a good estimate as to when the final Yasa compliance information will be released? Guillaume.
Yes, I mean, very accurate, I cannot say, but the purpose is to have everything published in the first quarter of 2021. So until end of March.
A simple question and a simple answer.
Yeah.
So that's good. Thank you. Then a question that I see here, is the 200-meter position accuracy optional if the solution has the 1 to 1.5 signal transmission? Is that something for you, Guillaume?
No, we will require both. So our intent is to require for survivable accidents, 200-meter accuracy and the automatic transmission of 121.5 megahertz roaming signal. For survivable accident, meaning when the accident conditions are, let's say, survivable by an equipment such as an automatic ELT.
Okay, thank you. And again, if you move your microphone down, then because that has a better quality. I see some questions in the Q&A that are in, I think it's Spanish. My Spanish is not so well developed, so sorry, I will have to skip them, or if you can write them in English, that would be good. Let's see what the next one is. Does the Air Traffic Service Unit meet the ADT requirements if AOC is customized to trigger the data transmission in case of a distress flight envelope? So who could answer that question from the panel?
I can try, maybe.
Yes, go ahead, Philippe.
In fact, to trigger the distress tracking, in fact, we had a lot of discussion on the EUROCONTROL working group. And this is why we developed the ED 237 with 4 criteria that you need to comply with one of the 4 criteria to start transmitting the position while in distress. So we had many discussion about the number of criteria and so on. And these 4 ones are the one for which we consider that 95% of the case you are going to have within a few minutes the aircraft on the ground, so impacting the ground. So you may have different way to comply with these criteria. One could be the envelope, because each criteria would be dedicated to a specific type of aircraft.
Okay, thank you, Philippe. I go to the next question. Let me see, maybe one for Declan. Data sharing, what are those data? And is the aircraft operator involved?
Yeah, so the data sharing is defined. You will find further guidance in the ICAO Doc 10054, and you'll hear more about it tomorrow too in the ladder. But it's basic data on lat long and a timestamp. The intention is that the ladder will be able to capture additional data, and it would be available to the operator. In fact, in some cases, depending on your solution, it's actually the operator would be supplying the data to the ladder solution. But we'll hear a little bit more about that again tomorrow.
Well, in fact, it's this afternoon already in the second webinar. So this afternoon, Ian Knowles of ICAO will present the status on the ladder. And well, if for those who are asking questions, please keep your ladder questions for this afternoon for the second webinar. Question, Guillaume, for you. What is the status of document RMT 0400, and when will the final version be released?
Yeah, I think I already replied to this one. So
yeah,
first quarter.
Okay, then the next question, the system that will determine that the aircraft is in distress situation, will that be a new computer on board or a combination of existing computers?
I can try maybe to answer a little bit the question. I think that you will have a presentation this afternoon by Airbus, for example, that I say will provide a comprehensive answer. Nevertheless, what I would like to say is that back in 2009, at the time of the accident of A447, the computer were already, I would say, available to process the criteria and to compute some of the crittering criteria. So it was an important component of the safety recommendation to promote, I will say, or to promote ELTDT, because there was already an ELT, an autonomous system on board. So what was, between brackets, just missing was the link between the computers and the ELT. So yeah, both manufacturers will give example of computers that are providing or performing this computation of triggering criteria.
Okay, thank you, Philippe. And question for Guillaume on the Q&A. On slide 12, you mentioned that making data available to the operator is not yet required. Is this a change from the Notice of Proposed Amendment 2020-03?
No, because if you read the Notice of Proposed Amendment, as I said, it's published on the Yasa website, so you just have to Google search it. You will find that the proposal we made was to simply to require the automatic transmission of the data to what we call in the NP Search and Rescue Center, to make it available to ATS unit. And then we proposed guidance material to advise that this data is also made available to the operator. So this is not a new position.
Okay, thank you, Guillaume. Moving to the next question, it's really great to see all these questions coming in. So please keep sending them. We have some time to answer them. It's an opportunity. Is the selection of a transponder code 7700 or 7500 triggering the ELTDT?
Yeah, I may try to provide an answer. So when we built the ED 237, it was one of the triggering criteria that was assessed. and it was considered that no, it is not a triggering criteria that will be accepted. Just for example, ELT can already be activated in flight by the crew, and it never happened because, in fact, the crew are making their best to recover the aircraft, and DLT is never activated in flight. So it is why we consider that we should have an automatic means to activate the distress tracking when appropriate.
Thank you, Philippe. I'm just looking at some other questions. Oh yeah, the one question did we answer that? How do we determine that a crash is not survivable? Should we not assume by default that any crash is survivable until proven otherwise? It would be tragic to repeat occurrences where crashes were only non-survivable because no one came looking for them.
Yeah, I can maybe give some elements on this. It's true that it's not a black and white thing. Even in accidents where the impact forces were very high, there have been some of them some survivors, sometimes only just a couple of survivors, but still. So it's in the slide I've shown. It's a bit, of course, for the purpose of PowerPoint, it's oversimplified. What we mean here is that for the conditions that have been defined, the crash testing conditions that have been defined for an ELT to perform, and that are deemed, let's say, capturing most of the survivable accident, we would like high accuracy. For the others, we would accept not so high accuracy. I'd like also to add that to comfort this, we have made a review of historical accidents, of investigation reports of historical accidents to look at the survivability rate. So we have, based on this, established, let's say, this criteria.
Okay, thank you, Guillaume, for that. There are quite some questions for you in the Q&A, so please have a look at them. I continue with a next question. Are both the ELTDT manufacturer and the aircraft OEM responsible for meeting the nuisance COSPA-SARSAT transmission criteria? Well, this is a question, I think, to also COSPA-SARSAT. We will hear about COSPA-SARSAT on tomorrow's webinar 3. A nuisance trigger may be an ELTDT fault, or it may be an error with the trigger parameter. I presume trigger parameters are unique to each airframe and therefore defined by the aircraft OEM.
I just can provide a part of the answer. On the ED 237, again, we consider that we may expect a nuisance trigger, and these nuisance triggers, the level of nuisance trigger should be of less than 2 10⁻⁵ flight hours, because we considered when working with the RCC that it could be the maximum authorized nuisance trigger that you can expect, even if we believe that with a new generation of ELT, we may have less false positive trigger on automatic, on ground, or whatever, on maintenance. So we can expect false positive while in flight, and with a minimum rate, I would say.
Thank you, Philippe. Guillaume, could you please clarify which devices are required on board to meet the ADT requirements?
Which devices? So in fact, we do not require a specific device, but in the NPA, we address 3 technologies or 3 types of solution which are deemed more mature that we want to to facilitate, which are the ELTDT based solution, the solution based on high rate tracking, as I mentioned before, which can use other transmitters than an ELTDT, and the solutions based on an ADFR, an automatic deployable flight recorder. But we do not restrict, let's say, the possible solutions to these three ones. Just for these three ones, we have provided more specific conditions to facilitate the approval.
Okay, and thank you. Another question that I see for you, Guillaume. Can you expand on the reason why Yasa has removed the passenger criteria, 19 passengers, for heavier aircraft, where ICAO does not make this distinction?
So I must correct this. Yasa has not removed this, and I'll try to be very short. But with regard to implementing rules, EASA does not adopt implementing rules. They are adopted by the European legislator, which is the European Commission, the European Parliament, and the Council. EASA only proposes rules to this legislator. In this particular case, CAJAN MPA 210 was adopted under a non-normal, let's say, express process directly by the European Commission on the member states without a prior proposal by EASA. And this was in the aftermath of MH370 accident. There was a declaration by the commissioner responsible for transport at that time that by the end of the year, Europe would have response to such an issue. So you can see there is some kind of political issue. At that time, there was a negotiation between states, and the rationale behind was that we wanted to include cargo flight, but to not include necessarily business jet flights. And this is why we have different applicability criteria from ICAO.
Okay, thank you, Guillaume. By the way, the questions in other languages than English, we will record them and we'll try to answer them later. And question I see here, so far it is not allowed by ICAO to activate the ELT while in flight. Is this going to be changed? So the in-flight activation of ELTs. Who could answer that question?
It seems to me that it's not forbidden to trigger the ELT in flight. So it is the purpose of ELTDT.
I would say it's not forbidden, and even the aircraft flight manual of many aircraft model, let's say, provide instructions for activating the ELT in flight. Of course, it should be activated only when it is justified. So.
Okay. Question for Declan. You presented the development of the GADSS or the CONOPS. You were involved from the beginning. So could you elaborate a little bit on sort of the obstacles and the main issues that had to be taken with the development of the CONOPS and reaching the point where we are now?
Yeah, so it was a very challenging process in the sense that we needed to establish that working group very quickly, and with expertise from a very broad set of backgrounds. So, you know, we needed SAR experts, and we were happy to get Scott Constable, who I see is on this call, from Australia. And then we needed, you know, people with operations backgrounds, ATC, airworthiness as well, to fill into the system, you know, the key issues. I think what was clear through the process is there are always conflicting priorities for different parts of the industry, and you know, you have to try and bring those together. So obviously for the commercial industry, they didn't want to see overly complex systems that didn't, to their eyes, bring an awful lot of benefit. Whereas from the regulatory perspective, we were very keen to make sure that you know, this sort of scenario could not happen again, or highly unlikely to happen again. I think one of the big recognitions, too, for me at least, and especially at the time on the Air Navigation Commission, is that there are a lot of standards and recommended practices in Iko annexes that aren't effectively implemented. And, you know, in the case here, when we looked at search and rescue regions and the implementation of SAR as per, you know, Annex 12, etc., you could see that there was big gaps. So a lot of work has been put in the last 3-4 years by ICAO at the regional level in trying to improve the SAR capabilities. And I think you would have heard Sylvia Gare reference it this morning. In Europe, we had a SAR task force in Europe, and that came from the analysis in the GADSS. So it's not just, I guess the point I'm making is that the GADSS itself is one set of work streams, but actually as well, out of this whole process, there was other work as well in other areas that isn't evident in the GADSS that was presented here this morning.
Thank you, Declan. Guillaume, over to you, and please, for all the participants, if you have questions to this excellent panel, it's now time to write them. Guillaume, there are two questions I think you are best placed to provide an answer to. Regarding transmitting a deactivation signal after 1 minute, are there a maximum time for forwarding the updating to the coordinating RCC, 20 minutes? Do you see that question? I
don't see it, but indeed we intend to also set a time objective for the transmission of the activation signal. Otherwise, they would be useless. Huh? So yes.
Okay. And then another question. The way I understand it, the ADT system will only be required for aircraft with a maximum takeoff weight above 27,000 kilos and over 90 passengers. What about for aircraft with lower MTOW, but can take up to 39 passengers?
Yeah, so I'll jump in on that, Henk. So at the time when we went through this, we did look at how far the ADT requirement should extend. Now, it was agreed at the time that we would keep it to the larger aircraft as defined, but it is in the work program of the GADSS to reassess again in the next couple of years as to whether it should extend further. But what you're seeing too is, you know, we'll see how the ADT solutions evolve. You know, with the introduction of ELTDTs, it might be quite easy to introduce it to the smaller aircraft. And so it might make the standard more palatable for the industry. But that is part of the work program for ICAO, and it will be looked at.
Yeah, I could add also that maybe the safety case is stronger for aeroplane above 27,000 kg maximum takeoff mass because of their range. So they might, let's say, get missed far away from a seashore or over a desertic area where there is no too good coverage, neither by the civilian radars nor by the military. And this is what happened with MH370. So 27,000 kilograms, basically it's starting with the regional jets. Below you have the turboprops on the small jets. So there is also a kind of proportionality aspect here.
Okay, well, thank you all for this. Are there some final comments from the panel? No. Very good. So I would like to thank you, Philippe, Declan, and Guillaume for your presentations and your replies to questions. And that concludes the first webinar of 3. Goodbye from now.